The new study is the first comprehensive reconstruction of how the ice sheet and its many glaciers are changing, says lead author Beata Satho, an associate geology professor at the University of Buffalo.
What is exciting that we see in this complicated data set how some pattern begins to emerge.
Greenland is a huge island. If it were a country, it would rank 12th in size among world nations. 80% of it is covered by ice, and if that ice melts completely, global sea level would rise over 7 meters. Current climate models predict loss over the entire ice sheet based on data from 4 glaciers. The new study uses a massive data set from surface elevation changes at 1,000 locations.
We all know that the ice is melting, we are losing ice, but it's also giving the spatial and the temporal pattern. Which areas are vulnerable, which areas are changing rapidly, which areas are changing in a different way than we expected.
The scientists checked the new data against the current climate models for Greenland. While some points match, Satho says the old models are way too limited.
So having more data, we can have a much more accurate way of understanding how the ice sheet is changing now, and knowing that we can predict it much more accurately what it will do in the future.
The study finds that glaciers next to each other are not necessarily changing in the same way. Some grew thicker even when the temperature rose. Others exhibited accelerated thinning. Some displayed both thinning and thickening with sudden reversals. Satho says the researchers look for patterns that took into account local effects like ocean temperature, hydrology, and water under a glacier.
So giving a simple example, if the ice gets warmer, the glacier can flow faster. And that faster flow will deliver more ice into the ocean. We call it ice dynamics, and it's a very important part of understanding what is happening. So that's a way to say it is the way glaciers and ice sheets are responding to the change of climate.
Satho says the study shows why detailed, widespread monitoring is critical. She says given the complex nature of glacier behavior, good data is crucial to building better models, and those models can help coastal communities respond to rising seas. Rosanne, Skirble, VOA News, Washington.